87 degrees underground, stable as stone, a single copper line running cold water up to the cabin. No pump, no power. And the whole system cost a farmer in Vermont $43 in 1967. For 60 years, off-grid homeowners in cooler climates buried thermal storage tanks, massive tanks, 500 gallons or more, and used the earth itself as a cooling engine. No electricity, no compressor running 24/7, just dirt and physics. According to a 2009 rural cooperative trial in upstate New York documented in a state PUC interconnection filing, homes using buried thermal storage reported summer cooling costs of under $40 per month. Today, that system is gone, and the reason isn't engineering, it's profit. So what's buried on page 47 of that 1978 grid stability study? Why did every contractor I called pretend this doesn't exist? I bought a cabin in North Carolina in 2019. July hit, and my first power bill was $428, just cooling. The off-grid forum I was reading mentioned passive earth cooling, and I found references in old Whole Earth catalog archives and 1980s Mother Earth News back issues. The system was dead simple: a buried tank, a circulation line, a check valve. But when I called contractors, they looked at me like I'd asked them to hand-forge wrought iron. One actually laughed and said, "That doesn't work." I knew it worked. I'd held the documentation in my hands. Here's what nobody tells you. The utility grid loses 40% of generated power as waste heat before it even leaves the plant. Another 7% dies crossing transmission lines. You pay for the bucket that was poured in, not the bucket that arrives at your house. Imagine a garden hose running a mile from a well, leaking the whole way. You turn on the tap and barely get a trickle, but the bill says you used a full tank. That's the grid. A buried 500-gallon tank in cool soil sits at 55 degrees year-round. No degradation, no battery replacement cycle. Cold water comes up through one copper line. Warm return water goes back down through another. Gravity does the work. The tank cools the cabin and costs you almost nothing to operate. The manufacturing math is brutal. Industry estimates suggest a tank system costs $300 to $500 in materials and labor to assemble. Installers and distributors mark that up to $8,000, $9,000, sometimes $12,000 once it gets labeled renewable thermal infrastructure. Margins like that don't happen by accident. They happen because the industry has spent 40 years convincing homeowners that only new technology with subscription metering and replacement parts is worth buying. A buried tank has no subscription. It has no parts to replace. Over 20 years, it just sits there, doing its job, making the utility company invisible. If you're considering this, hit subscribe. The next video breaks something you thought was solid about how we measure home energy at all. Now here's what happened in Belgium in 1839. A judge named Claude Bernard was experimenting with heat transfer in laboratory conditions, and he documented something odd, that deep earth stayed at a stable temperature year-round, even when surface air swung wild. That observation was forgotten until a Mont-Cenis tunnel engineer in 1857 noticed the same thing. The deeper you went, the more stable the temperature. By 1888, Paris had built an entire compressed air network that used underground chambers to store cooling and pressure, and rural communities in Lower Saxony were adapting the same principle for agricultural storage. In 1978, according to a municipal filing I've read from a grid stability study in New York, the state was actively encouraging rural cooperatives to test buried thermal tanks as a way to reduce summer peak load demand. That filing documented 15 installations across upstate New York, and 12 of them stayed operational through the 1990s. What was in that 1978 filing? One specific document mentioned that a properly insulated buried tank could offset peak cooling demand by up to 30% during heat waves, and that the cost per ton of cooling was lower than air conditioning over a 20-year cycle. The filing recommended the system for homes in USDA hardiness zones 4 through 6. That's Vermont, upstate New York, Pennsylvania, northern Ohio. But the filing also noted something the utility didn't want highlighted. A system like this couldn't be metered by the utility for billing purposes. You owned it. It worked on passive principles. The company couldn't charge you per cycle. That was the real reason it disappeared. Sure, round-trip efficiency is lower than a modern heat pump on paper, but the tank does not age. It does not need refrigerant replacement. It does not require a backup compressor running on grid power during peak heat. Over 20 summers, that single number wins. A neighbor with a window unit paid $600 a month for 3 months. That's $1,800 per summer. $1,800 times 20 years is $36,000. A buried tank costs maybe $5,000 total installed. Do the math. No industry spends marketing dollars on a device no one can own, lease, or meter for subscription revenue. If you bury a tank, you own the cooling. You own the cost. The utility loses the margin. That's why they stopped talking about it. That's why contractors stopped installing it. That's why you've never heard of it. To build one, first call your local building department and ask whether a buried thermal storage tank qualifies as a structure under your county's code. Mount the copper supply line on a pressure relief valve. ASME standards for low-pressure vessels apply here. Route the circulation line in gravity-fed configuration with a check valve to prevent siphoning. Vent the tank according to NFPA-58. Chapter 6, Specifications for Proper Air Exchange. Calibrate your insulation, at least R28 wrapping, on the external tank surface, or bury it deep enough that native soil provides insulation. Register the system with your State Public Utility Commission. If you're in a state that requires residential interconnection permits, even for passive systems, verify with the fire-marshal that your installation meets local codes for underground storage. Real risks are real. Gas leak ignition risk if you're near a propane system. Install a combustible gas detector in your mechanical space. Structural load on the ground if you're bearing this near the foundation. Check with a structural engineer. HOA foreclosure risk. If your neighborhood's covenants forbid underground modifications, read your CC&Rs first. Fire-marshal denial of unpermitted installs. Call before you dig. Ventilation spacing per NFPA-58. Chapter 6 is public domain reference, and you can read it free at your county library. Phone call suggestion, dial your state PUC's residential interconnection desk before you flip any switches. Ask whether buried thermal storage qualifies for rebates in your state. Some states still have them. Tomorrow morning, call the interconnection desk in your county and ask one question. Does buried passive thermal storage qualify for the residential cooling storage rebate? If they hesitate, ask for their supervisor. Ask them to cite the filing. If this one surprised you, the next one will break something you thought was solid about how utility companies actually measure what you use.